right, good morning, good afternoon, good evening. My name is Mike, and welcome to the Architect Podcast. Hang on one second here as I look for my audio. I did have some audio issues the past couple weeks. Want to make sure that we're okay here. Okay, looks like we should be good to go. Okay, awesome. So welcome to part 2 of the Portable Agent Platform. I really can't wait to actually get into the second part of this because we actually built the actual platform with the agent. I'll talk about what that looks like. We'll go over all the pieces and parts and the components. But before we do, I want to just take a step back to part 1, where we talked about the infrastructure of the portable agentic platform, and I talked about it running on the Minisforum MS02 Ultra. So this is, hang on, let me just share my desktop here. Okay, so this is what it looks like. Okay, it's a very small form factor, right? It's not a Nook size, right? It's bigger than that. Think of it something like a book, right? A little bit bigger than a large encyclopedia, as an example, right? And within this is packed a ton of power. And so I just want to just review this really quick because I think for what I'm running on this and for what it is, I think it's actually pretty exciting. So you can see here a picture, top-down picture of it with the case off. It doesn't have a top cover, right, where the cover comes off. Each has a each side has a cover. It's basically a chassis that it sits into, right? So you basically unscrew the thumb screws, you pull the sled out, and the sled is this body right here of all the components. And it has this heatsink fan built in. And by the way, it's a very thought out chassis build from a cooling perspective. I'm going to talk about that here in a second because there's some things missing, which I'll talk about here. But essentially, what they've done is they've carved out the chassis in specific zones. Okay, so if we go in here and I want to just use my drawing tool here, the power supply, right, would be zone 1. Okay, so the power supply basically gets it's the cooling, right, through here, through these vents, right, and then it blows out the back here. Okay, so and essentially, what I'm doing here is it's basically saying, okay, this zone is for the power supply, and it sucks in air, right, and it sucks in air across, and sends it out the back. The other thing next to it, right, is this card that you see here. Okay, now this doesn't come with every, oh, hang on. This doesn't come with every configuration of this platform. You have to specifically get the Intel 285X, right? HX, excuse me, which is the CPU, which is 24 cores and 24 threads. So it's the Intel Core 9 Ultra. It's a mobile platform to keep the power and efficiency there in the small form factor. And basically, what it's giving you is 24 cores. I think it's 8 performance cores, 16 efficiency cores, and you're getting that efficiency within the mobile component, right? And this is the add-in card that comes with the 285HX version. And this add-in card is basically layered in, I believe, a 8 times PCI 5 slot on the custom motherboard for this system. And it's a dual 25 gig 800 series Intel NIC plus 2 NVMe ports within the card. So essentially what I have here is I had the 25 gig NIC here, and then on top of this card, underneath this heatsink, I have an NVMe, and that's the boot drive for AHV. So we'll talk about the software here in a little bit, but that's what I'm using as the boot drive for basically the OS, the virtualization stack for this platform. So here we have the CPU and RAM. Okay, now it's going to be a little bit different from what I'm talking about, right? You can't see all the RAM slots. So you have RAM slots here, okay, underneath this heatsink. You have two SODIMMs. And then on the back of this, okay, you also have another two SODIMMs. So you have four SODIMM modules that you can actually populate up to 256 gigabytes of SODIMM DDR5 RAM. Okay. So I already had 96 gigabytes in another platform that I used to have before I sold it. I pulled that out. Okay. And I repurposed it for this, and I purchased another 96 gigabytes to have a unified 4 DIMM architecture. So essentially, I don't have 256 gigabytes. We'll talk about some of the limitations on that. I have 192 gigabytes total in this platform. And then, of course, under this heatsink here and the heatsink fan, which is this other zone, right, is the cooling for the heatsink here above your SODIMM modules, as well as the CPU, right, which again blows the air out the back. Now, between this, and you don't see this here because I don't have it installed yet, but between this zone here for the CPU and where the GPU port is, right? This is a by 16 5X slot, okay? And it's essentially PCI Gen 5.0. And what I have in here is, as you can see, the NVIDIA RTX 4000 SFF Ada version, not the Blackwell version. The Blackwell version just got released. I believe the Blackwell version added 4 gigabytes of RAM to what it used to be. So this card basically has 20 gigabytes of GDDR6X memory. Okay, it's low profile, very very small. It can go into a 16 slot, which it does, and then of course it evacuates the air out the back here. So you can see here that it's very well thought out, and you can see the front is all ventilated. And so all the air travels across all of these components to keep it somewhat cool. And it's very hard to do that within the small form factor solution, right? Because it is small form factor, it is tight. It's hard to keep these components cool because they do run hot. They don't run necessarily cold. And what it does is basically it gives you kind of these zones within the platform. Now, between the GPU and the CPU heatsink, you don't see this here because it's not installed. They do have a layer that goes across the top of this area. So let me just use this white here. Okay. And it basically separates, right, these two areas here, right, from a cooling perspective. So there's a wall, basically a plastic wall that sits between the GPU and the CPU area, and that again gives it its own area of cooling, right? Its own place within the chassis for cooling. So just to reiterate, very very small chassis, very small platform, very portable, can fit in a backpack. Okay, that's the whole idea of this. It includes a power supply, comes with a 25 gig, a dual 25 gig NIC if you get the right platform, a 285HX. It has two NVMe drives. And then on the back of this, right, you have the two SODIMMs under this heatsink here, the CPU under the large heatsink, right? And on the back, you have two Gen 4 SSD M.2 slots and two SODIMMs. The SODIMMs are cooled by the chassis back, okay? And then for the NVMe slots on the back, which is our core storage, it comes with basically heat sinks and the thermal pad that goes between the heatsink and the NVMe device, where you actually place those on your NVMe. So you can buy NVMe's without your custom heat sinks because it won't fit anyway. And then this solution comes with two heat sinks you can place on those NVMe devices on the backside. And then, of course, you have the GPU. So again, very, very powerful platform for such a small area. Some people may think, well, what if I get the Ryzen AI 390 HX 395, which gives me 128 gigabytes of unified memory, or I look at the NVIDIA DGX Spark, which is extremely expensive now. I think it's over $4,000. Now the Ryzen AI 395, I think last time I looked at it, it was over over $3,000 as well. This platform, without the RAM, without the NVMe, without the GPU, was $1,100. And then if you add the RAM, the GPU, right, you're still up there from a cost perspective, right? And so the question really becomes: is this the right platform for you, right? Because again, the Ryzen AI 395, which comes with 128 gigabytes of unified memory, right? I believe a 16 core CPU, um, is fairly powerful in its own right. And then the DGX Spark, DGX Spark, I think, is another class. It is ARM based. That's one of the things you have to kind of work around, and depending on what you're going to do, right? This to me is more of a customized solution where I can add in memory over time. I can add in NVMe over time. I can swap out GPUs. For example, this is an expensive GPU when I bought it. I'm not going to sugarcoat it. The Blackwell version, I want to say, is $1,400, and it's only 70 watts, and you're not getting a ton of memory bandwidth, right? I think it's like 250 gigabytes of bandwidth. It's very, excuse me, it's a little bit more than the DGX Spark in bandwidth, but of course, the DGX Spark, what lacks in bandwidth, has much more unified memory and can support larger amount of models, right? Not amount of models, right? As well as larger models, right? And so I'm bound by the 20 gigabytes within this RTX 4000 for models I want to leverage for GPUs, okay? Or with GPUs, excuse me. You don't have to go this route. There are other low profile cards you can place within here. The other options would be an NVIDIA RTX 4060 low profile or a 5060 low profile. Of course, in those solutions, you're basically more than having the RAM. They're only 8 gigabyte VRAM GPUs, but you could still get away with that, and it's much more cost efficient, right? I think you can get those GPUs for between, I think, 350 today, $350, right? So an RTX 5060 low profile, 8 gigabyte version for $350. So much more cost efficient, however, less memory. One thing that you will get out of the RTX 5060 is you'll get better memory bandwidth than this, because you see the cables over here. If you look at these cables in this area, one of these cables, right, is a uh, 8 port, I believe, an 8 port or a 6 port cable, or combined, where you have a six pin with the 8 pin that connects, and you can actually provide power to the RTX 5060, which is a requirement because it has much better memory bandwidth. Okay, so what you're trading off with the RTX 5060 versus the RTX 4000 SFF is efficiency and memory capacity, okay, from the VRAM perspective. Okay, so that's the hardware platform. Just I want to go back and just talk about it. This is what it looks like. This is how it's set up. And this is and basically what I have in this platform to accommodate. Now, what's compelling about this is not the hardware, right? I mean, the hardware is fun, right? It is compelling from it's portable, it's more customizable than the DGX Spark, although there's trade-offs, or the Ryzen AI 395HX, right? There are trade-offs. Okay. One of the reasons I went with this is because of the way I can customize it, right? So if I want to replace the RTX 4000 SFF ADA with a Blackwell version or even a Rubin version coming out in the future, I could do that, right? If I want to upgrade my memory from 192 to 256 gigabytes of memory, I can do that. And I can run much more other workloads outside of AI on this, right? So like the Ryzen AI 395 Max only max out 128 gigabytes of unified memory. Now it's great for GPUs, but what else can I run on it, right? Meaning if I start using that memory, what other workloads can I run on it from a demonstration perspective? Like, so I use this from a demo environment, a portable demo environment. Okay, so I want to get into the software, right? So, and this is really the platform, right? And it really ties back into the Nutanix Agentic AI platform. Okay. Now, the Nutanix Agentic AI platform is not quite out yet. Okay. What I'll just say, and I don't want to say it like it's all in brand new because it's not. All right. What the Nutanix Agentic AI platform is, okay, it really is a culmination of our tooling, our platform that we already have, right, with some advanced features and innovation that are happening around the platform. Okay, so you know, we announced the Nutanix Agentic AI platform, um, like it's it looks like a new product, right? And the reality is, it's not. It's what we've done is we've built on the solid foundation that we already have today. Okay. And I'm going to talk through what that looks like because it's not quite ready yet. In a couple of months, you're going to see a release, the next release that for software release for our platform. You're going to see capabilities brought into the current platform that are going to expand the innovation and feature set, right, to accommodate for a better agentic AI platform. Okay. And so what I'm showing you today is basically pre-agentic AI and pre-innovation, right? But you're going to get an idea of what this is going to look like. So what I'm showing you right now is essentially Nutanix Cloud Platform. So the foundation. All right. So Nutanix Cloud Platform essentially includes, okay, it includes um, the core infrastructure underneath. So the hypervisor, which is Acropolis hypervisor. Okay. I'll talk about a little bit more about the innovation that's coming there when it comes to agentic AI. And then the core management capability, right? So the storage stack, right? The networking, the advanced networking, right? All of those things, all right, in the core foundational platform. And a lot of folks will come back and say, well, Mike, why would I even introduce a hypervisor into the mix of, you know, accelerated compute workloads, right? AI workloads. Isn't that adding additional overhead, right? Et cetera, et cetera. So there are two schools of thought, and we're going to provide you both options. Okay. In typical Nutanix fashion, we're going to give you flexibility around this. The first school of thought is if I need to provide a multi tenant AI platform, what you need to have is you need to be able to provide relief, right, from noisy neighbor issues. So if I have a tenant that's sharing a platform, a multi-tenant, excuse me, that's sharing the AI platform, how do I alleviate noisy neighbor issues? How do I partition, and I'm using this term lightly, how do I partition the resources for that specific tenant? Okay. And people will say, well, that's, VMware's been doing that for forever with, vCloud Director, and, they do resource pooling in vCloud Director. They can do, multi-cluster, all of that, right? I'm talking about AI workloads now. So I'm going deeper into the infrastructure. So when you look at this, right, and I want to just take a step back, not just VMware, right? There's other folks that are looking at how to deliver the AI platform. And most of those folks are focused on Kubernetes. And by the way, Kubernetes is a big part of this, but they're focused on Kubernetes as the layer, the platform layer, right? That does everything, manages the infrastructure side, et cetera. So when you look at partitioning in Kubernetes, it's extremely operationally heavy. Okay. And what I mean by that is, Kubernetes, by default is not NUMA aware, right? By default, cannot partition DPUs, cannot partition, can partition GPUs, right? I'm not saying you can't, but with the help of right, the NVIDIA GPU operator as an example, right? MIG, vGPU backed MIG, those types of technologies, right? But the issue becomes when you start looking at how NVLink works within those platforms, or NVSwitch, right? How do you partition that, right? How do you partition those things? And that's what I'm talking about. So when we talk about AHV and the innovation that's coming, right, for the agentic AI platform, we're talking about what we call topology aware hypervisor. So the ability for the hypervisor to partition off resources, NUMA awareness, memory awareness, right? Partition, DPU, right? DPU, networking partition, right? NV switch partition, NV link partition, GPU partition, all of those things. And so when you look at it, think of it as a multi-tenant, enabled platform foundation, right? That allows you to partition those resources out to specific tenants or specific users in the community, right? So again, do you want to have an AI platform for your enterprise that, okay, we're going to build a separate AI platform for this group of users and a separate one for this group of users. And you can go down that path. I'm not saying you don't have to go down that path, right? You certainly can go down that path and still get a multi-tenant approach that way, or say, okay, this group of users only uses this, or it's for this use case, this infrastructure. But the reality is, as you build out your AI factory, okay, and I use the term AI factory lightly, I'm not talking about, GB300s. It could be GB300s, right? But to me, an AI factory is, I built an AI factory in the MS2 Ultra, right? It's generating tokens, right? Manufacturing tokens, intelligence, right? So to me, that is an AI factory. And so, when you start looking at your AI factory for the enterprise, though, and you build this platform that you want to share across use cases, across users, et cetera, right? This is what I'm talking about. You can do some of it in Kubernetes, not all of it. It's very heavy. It's very operationally heavy in Kubernetes to do that. Okay. And so that's one area where we're focused on. But also what I stated before, why wouldn't I just use bare metal? If you're not really focused on a multi-tenant environment, you're not as concerned with NUMA awareness, whatever, or it's a smaller environment using a specific set of users, then you can go Kubernetes bare metal. And we offer that as an option too. And I hate to say option, but a flexible solution as well, right? So you're going to have the ability to choose between both solutions, okay? So again, this is Prism Central. So this is our multi-cluster management tool. Okay, now I say multi-cluster even though I'm using one cluster. And you can see here, I have one cluster called Construct. Now, basically everything I built here is based on the matrix, okay? And the reason why is because, I kind of made this agent, the agent we're going to talk about when we get to the agent, I called that agent Neo. And we're going to talk about the capability of the agent, hopefully at the end of this call, if not in part 3. So you can see here the hardware. So if I go down here to hardware, I have my host. Okay. This is the MS02 Ultra, right? The Minis Farm Ultra. And this is running Nutanix Community Edition, right? Which includes Acropolis Hypervisor and AOS, which is our storage. We call it NCI. Okay. And so that's basically the storage stack and for the virtual machines, as well as the hypervisor layer. Okay. And you can see here the memory, and you can see I'm very, very memory limited on this platform. Okay. So this is going to talk, I'm going to talk about some of the things that I can't include in this that will be included in the real Agentic AI platform, like the advanced networks, capability like VPCs and offload to DPUs and, flow CNI, which is our CNI, which allows for, security across VMs and containers, et cetera, right? From a dual native perspective, right? From VMs and containers, right? And so I couldn't implement some of the things that would be in the agentic platform because I'm memory limited. And if I did have the full capability of the platform, 256 gigabytes of memory, I would be able to actually add in the flow CNI pieces, right? And I think down the road, as I look at how I'm going to grow into this platform, you will see me kind of roll this out, especially post GA of the innovation from that's coming, right? So there's the host, and then of course you create a cluster. It's only a single node cluster. It's running the latest version of Acropolis operating system, which is our core storage stack, and the latest version of Acropolis hypervisor, our hypervisor. Okay. The disks I talked about, you don't see the boot disk in here. The boot disk is basically a 250 gigabyte Samsung 980 Pro that sits on the NIC I talked about, right? The 25 gig NIC that has the dual M.2 ports. And then I have two disks. I have a 2 terabyte for controller virtual machine. That's a 990 Pro Samsung. and then a 4 terabyte 990 Pro Samsung for the basically the extent store, right? The core storage. So it's all NVMe. It's M.2. It's extremely capable, right? Pretty fast. But understand that this is a single node. It's on a commercial platform. It's not supported, right? This is a project I'm working on. You guys, if you watch me before, I've told you I'm a Nutanix employee, so you guys know that. But what I'm doing here is I'm delivering the art of the possible, right? What could be possible. Um, Thinking about how you can deploy an agent or what a localized agent could do for you or a portable agent. And this is the whole point of this, right? The idea is to be able to lift this platform up out of my rack, right? My lab, and go places with it. And if I need intelligence and I need agentic intelligence to take with me for a specific use case, I can do that and still have access, by the way, to super intelligence from the frontier or foundational model providers. And I'm going to get into that here in a little bit. You can see the GPU. This GPU is not supported, right? It's the RTX 4000 SFF Ada is a workstation GPU. It's not an enterprise grade GPU. So it's not a server based GPU. You won't see that in most cases at customers. Customers will be using RTX 6000 Pros, or they'll be using B200s or B300s, or they'll be using L40Ss. Not so much L40Ss anymore since the RTX 6000 Pro seems to be a better value, right? Um, those are what customers are using in the enterprise. They're not using RTX 4000 SFF 8s, not even at the edge. Even at the edge, and I have an edge solution, they may be using something like an L4 or a set of L4s. Okay, and I have that in my enterprise lab at home that's going through a rebuild right now, so I can't show you that. But essentially, the RTX 4000 is not supported. I had to kind of customize Acropolis Hypervisor to make it look like the RTX 4000 SSF Ada was supported. Okay, so I had to basically create a custom configuration for this GPU and allow AHV to see it. That way I can pass through. I have the ability to pass through the UI. You can see here it's in pass-through mode, right? To my Kubernetes node, okay? For the GPU, the AI workloads. You can see the NICs here, right? I only have one connection and I'm only connecting 10 gig. So I only have 10 gig. My lab is very small. It's a mini cluster lab, very, very tiny, but it does support 10 gigabyte, even though these are 25 gig. They're SFP ports. So I have an SFP to RJ45 adapter in one of the ports, and that goes into a Ethernet port, 10 gig port on my switch, my Ubiquiti switch. The other ones aren't connected. You can see here there's also a 2.5 gig NIC, right? There's also a 10 gig NIC that doesn't show up, I believe, because I'm using the GPU slot. So one of the constraints that you have in this platform is the amount of PCIe lanes. Okay, because it's a mobile platform. At the end of the day, it's not a Intel Xeon or an AMD EPYC that has over 100 or 150 or whatever 128 PCI lanes. It has like 24 PCI lanes, right? And so I have to, the platform has to adjust to what you're using. If you're going to pack it full of things, it's going to obviously turn some things off and on, right? The ability to use like Thunderbolt, may go away, isn't it? Because this has Thunderbolt, right? Or specific USB ports may not work because I've had this packed, right, from a PCI perspective. Okay, so let's get into the compute side of this and the VMs that I have running here. Most of these VMs, right, are to run the platform, and then I have a workload Kubernetes cluster, which we'll talk about in a minute. So the first VM, right, is called the Merovingian. This is my domain controller. Okay, so I'm running a Windows Server 2025 domain controller. Okay, and this runs basically DNS and domain services. Now, you may question, why would I do that? Why would I do something more lightweight, maybe an open source LDAP server? You could do that, and then have a small open source DNS server. You could do that as well. You don't have to do this, but it's 2 vCPU and 6 gigs of memory for this, so it wasn't that big of an overhead. To be honest, I have much more for me, I'm much more comfortable with Windows domain services than open source stuff, because that's what I see mostly at enterprise customers, and so that's what I work with the most. And so this is set up, like I said, Windows Server 2025 AD DNS, right? And this provides DNS and Active Directory services, not DHCP. So there's no DHCP happening within this server. I don't have a third-party DHCP service. AHV actually includes DHCP services natively within the platform. I'm doing this on this model because of how small it is and the overhead, the lack of memory that I have. Okay, so DHCP will be serviced or is serviced through Acropolis Hypervisor. I'm going to show you what that looks like here in a few minutes. In the enterprise, obviously, you would have your own DHCP services, right? More than likely, it would not be Windows. It'd be something else, right? And so here are the VMs. Again, this is the Active Directory. I'm going to skip the next two Morpheus, the next three, excuse me. Then you have the Prism Central VM. This is what the interface that I'm showing you right now. This is Prism Central. This is the consumption layer for the infrastructure side, right? And this is what I use to log in and show you some things. It's not it's basically the control plane for the infrastructure side, right? Multi-cluster control plane. It handles all my data protection, all the storage operations, my VM builds, all of that. More so, it's more of an API gateway as well, right? So I'm going to talk about that too in a little bit. The next VM you see here is called Nutanix NTNX. I'm sorry, let me just Hammer -1. So Hammer basically is the file services, right? This is the NUS or NUS solution, Nutanix Unified Storage. It's not running objects because I don't have enough memory to do that, and I don't need object services right now. But it is running our file services, okay? And so what I can do here is I can actually drill into the file server and I can show you what I'm talking about. So you can see here I have the file server Hammer, and I had this unified management, right, of my file services as well. Okay, and you can see here that I'm using NUS mostly, not fully, but 90% is mostly for read-write many storage PVCs for the Kubernetes cluster. Okay, and I'm going to talk about what that's for in a few minutes. It's for the AI workloads. It's also for the AI platform from a model storage perspective. And I'm going to show you how that looks like in a minute. But essentially, what you do is, I'm sorry, I clicked the wrong button. Essentially, what you do is you're providing, right, these services. In this case, NFS. I'm providing NFS, right, and I'm providing NFS v3 and v4, right, v4 specifically for these use cases. And I have the SMB protocol enabled just to have it enabled if I need it. Okay, but you don't have to enable this. So I'm just using it for NFS, and it's basically providing the read-write many storage for the Kubernetes cluster for AI. Okay. One of the things, let me see here, manage roles. And one of the things we set up here is we set up this REST API access, right? And that REST API access basically exposes the Kubernetes cluster, right? The ability for the Kubernetes cluster to talk to the Nutanix filer, the NUS servers, okay, through CSI, right? So you create a storage class. You'll use this as the REST API login user password to be able to communicate from Kubernetes, right, into NUS for dynamic creation of exports, NFS exports for persistent storage. So dynamic creation, dynamic deletion. Okay. The other components, let me go back here to the infrastructure. You'll see here they're called Morpheus. So, and they're pretty heavy from a CPU. This is where all the memory and CPU are being used mostly. Okay. So Morpheus is the Kubernetes cluster that's running our Nutanix Kubernetes platform. Okay. And essentially what I have here is and this is not set up in best practice either. It's more of an edge practice, I guess you could say, with no high availability. I have one control plane node here. I have one worker node here for non-GPU workloads. Okay. And I have one worker node pool that I've added for GPU workloads. So the GPU, if you go to this node, the GPU is passed through to that node. Okay, so that Kubernetes node, right, is basically providing the GPU, the accelerated compute for the AI inferencing workloads. Okay. Now, if we go back here too, I just want to just point out too that all of this is interconnected, okay, from an API perspective, so and integrated. So one of the things that people always ask me is, Mike, aren't these like different pieces and components? And the answer is yes. Like they can be consumed in a different way, and they can be purchased from a licensing perspective in a different ways, right? And that's the flexibility of it, right? So if you start with the platform, right, maybe the first thing you need to address is I need to decouple myself from Broadcom, but I need a next gen platform to do that. Well, this is the infrastructure pieces I was talking about, the NCI, the NCP piece, right? Prism Central, Nutanix Cloud Manager, right? Nutanix Cloud Infrastructure. So providing the storage pieces, the if you need it. By the way, we also support external storage now, which is exciting, right? Pure, Dell, NetApp, and you're going to see some exciting announcements coming in a few months on supporting any storage platform. Okay, so that's exciting as well. All right. Now, I will tell you that VMs, right? You have VMs, right? From HV perspective, you have all the hypervisor capability with networking. And I'm not doing any advanced networking because Flow is not enabled, right? So you do have the ability to actually add in advanced networking features like VPCs, like being able to create VPCs, like doing struct, like doing struct layer 2, all of those things. And then we've added that we've um, expanded that into the Kubernetes layer. So not just for virtual machines, but also into Kubernetes. And we have our own CNI called Flow CNI. So if you think of Flow is networking, right? Flow is like our networking solution. It's basically provides advanced networking features like VPCs and things like that, as well as network security, okay, as well as DPU offload, right, as well as which is coming, as well as excuse me, which is here. I take that back because you can offload. There's SRIOV support, those things that are already here. But from an agentic perspective, like to support real DPUs, right? You'll see more offloading capability happening there. And then, of course, the integration of the Flow CNI, the container network interface, right, into Kubernetes and for Kubernetes, right, to provide that same capability, not just for VMs but also containers, right? So you had that unified approach for virtual machines and containers. I'm just going to show you some of the subnets here and how I have it configured. Basically, I'm using VLAN back subnets, not using VPC backed or VLAN backed subnets. And then I'm using, I have a single subnet called management. And then I have an IPAM subnet, right? That basically provides the DHCP services that you can see here. Okay, so I don't have to, enable DHCP on my Active Directory DNS server. It does it natively within the platform, and for this use case, it's perfect, right? Most enterprise customers, like I said, aren't going to be using our IPAM solution. They'll have their own IPAM solution, but a lot of commercial customers, SMB customers, they'll use our IPAM solution. All right. I will tell you this, there are specific requirements about using IPAM for specific feature capability. All right. So that could come up. So for a specific solution or a specific, specific solution capability or use case, you may be required to use our IPAM in that use case, right? For now. So I want to just get into the Kubernetes layer really quick. So this is Kubernetes. So basically I kind of, made this, the dark mode. So the infrastructure side is all dark mode here. The cloud native and AI side will be in basically in white. Okay. So this is the Kubernetes platform. And so what you're seeing here is running on the VMs I showed you here, this Morpheus here and the control plane, as well as this. This is the NKP control plane, right? And it's we call the NKP management cluster that I'm logged into here. All right. So you can see here the management cluster. Now, you would not in practice, right? This management cluster would just be for managing your Kubernetes environment, right? You wouldn't attach workloads to this. Okay, you just wouldn't do it. This is the control plane. In my case, I added a node pool with the GPU to the management cluster for the AI workloads because I'm so limited on infrastructure. I'm limited on memory. Okay. And even if I had the full 256 gigabytes, I still would be limited on memory to deploy a full management cluster, right? Let it go. Or you can see all the errors that are coming up. It's because I'm very limited and I'm maxing out these resources, right? And I just have it, I just have it enough, right, where I can actually leverage this and have a little bit of breathing room, right? I think I'm using 98% memory, which is pretty high. Like you wouldn't run that in production, right? You wouldn't run 90% memory utilization in production, right? This is a lab demo environment, so I'm going to do that. Now, within the management cluster, right, I have the ability to provide all of these core services. So what NKP provides you is I don't want to say turnkey, it's very marketing, a production ready Kubernetes experience out of the box. Okay. And the out of the box feature, it may sound marketing, but that's what it is. Essentially, when I deploy NKP, right, I'm giving you access to a production ready Kubernetes environment. So it's not like standing up Kubernetes and then I have to, now I have to integrate CNI, observability, security, ingress, load balancing, uh, log aggregation, log visibility, alert visibility, alerting, cost control, certificate management. We're taking care of all that for you from a lifecycle perspective. We deploy it for you. So you can see all these things that we've deployed, right? The PLG stack is deployed, Prometheus, Loki, Grafana is deployed automatically, and you can go to those, right, and get visibility and dashboards that are already built within the platform, right? Or you can customize these dashboards. Okay. If you want to look at cost, right, we deploy open cost, and you can get some visibility. And again, some of these services may not work, right, or maybe slow, excuse me, because of the limited infrastructure I have. But now you can get an idea of cost, right, and what that looks like, right? So I'm just kind of giving you just a quick view into the platform services we provide with Nutanix Kubernetes Platform. And you can unify this across anything. Okay. And what I mean by that is you get the same stack on bare metal. This is running on virtual machines on AHV. I told you why I'm doing that, right? Because I want to take advantage of the topology or hypervisor when that's available. Okay. But you can run this on bare metal. You can run it in the cloud. You can use EKS, right? You can run it on GCP. You can run it in Azure. All right. And you get a unified level of production grade Kubernetes wherever it's running. Okay. And there's a lot of value in that. A lot of customers are looking at Nutanix Kubernetes Platform or using and deploying Nutanix Kubernetes Platform to overcome the challenges in a multi-cloud hybrid environment or a simplicity type, a simplified solution that provides you all of the core platform services. Now, you can see other things in here like the GPU operator, which is extremely important, right, for AI workloads, especially since I have an RTX 4000, right, GPU, right, which is an NVIDIA GPU, right? And, backup, right, Valero. So all these things, the Kubernetes dashboard, etc. Let's get to the node pools though. So I wanted to show you this really quick. So when I deployed this, I only deployed one node for the control plane, one node for the worker. And then later I added the worker GPU node. Okay. And you can see here that if I edit this, right, I had the GPU node, right, etc. Okay. Now, one of the things I found with this, and I have to actually talk to the reality is you don't see a GPU on here because the RTX 4000 isn't supported. I had to manually pass that through at the VM layer. But if you had a GPU that was supported, okay, you would be able to use vGPU or pass through depending on the profiles you have set up, whether it's MIG or vGPU back MIG or vGPU, right? You would be able to assign those, right, to your Kubernetes node. The only reason you don't see it here, like I said, it's not supported. So that RTX 4000 SFF ADA is not whitelisted, right? NKP doesn't see it as a valid GPU, okay? But I do have it pass through to the node at the infrastructure layer, and Kubernetes does see it, okay? Now, I haven't looked into it. There probably is a way for me to kind of finagle some code which I did for the Prism Central, for Prism, right? And excuse me, AHV, to allow for us to pass through the RTX 4000 Pro, RTX 4000 SFF80, excuse me. There probably is a way to do that in NKP2, but I haven't looked into that yet. But it's working, so I'm not really that concerned about it. Okay, so that's the Kubernetes environment. One of the things I want to just go to is the application. So this is basically the application catalog where there are services that Nutanix will provide natively and services that third party provides. So you can see the third parties, right, that we support, like Grafana, Loki. And one of the things I just want to point out really quick, Logging Operator, is we lifecycle these, right, for you. So even though these are open source applications that we deploy, we go through the lifecycle manage the deployment as well as the upgrades and updates to these open source tools, right? So you don't have to worry about, oh, I got to do this one off for Grafana, or I have to do this one off for FluentBit, because we validate the versions that work with the next Kubernetes version when you upgrade the cluster. Okay, so that's another challenge, right? A challenge of, okay, when I upgrade the Kubernetes cluster, I have to actually look and see now all of the open source tooling, the versioning, right, and how that's supported in the Kubernetes environment. And so we handle that for you from a lifecycle perspective. But I want to point out, right, there's third-party tools here, right? So some of these third-party tools have everything to do with supporting the AI platform services. You can choose to deploy them within the application catalog or not. So in my lab, I did not. I did not deploy these tools within the application catalog because I'm at the cutting edge of versions within Nutanix, right? So I'm the latest version of the AI platform software, the most recent version of the NKP platform, the most recent versions of the infrastructure and the files platform, right? The NUS platform. And so I chose to deploy these tools that are required for AI, not from the catalog, but you can. So K-serve is a requirement. You can deploy it right here. Just hit enable, it'll automatically deploy, right? The GPU operator, right? That was actually deployed, right? I actually did deploy that. I think I showed you that. Wait a minute, it's down here, I think. Yep, GPU operator, I did enable that. That was deployed, okay? The Envoy gateway, which is required for our AI platform, you can deploy that through the application catalog. So what I'm saying is you can deploy these applications through the catalog, and we'll lifecycle these applications for you and align them to what's required for the AI platform. So when that's done, so when you do the prerequisites like Envoy, GPU operator, Knative, right? You can then now deploy the Nutanix Enterprise AI Platform. Okay, so we're making it very, very easy to actually deploy, right, to get you to the AI platform. Because at the end of this, right, I need to get to AI services. I need to get to inferencing, agentic management, MCP tooling, model management, all of those things. AI gateway, right? That's what I'm trying to get to, right, to support my agents. Okay. The other thing I didn't talk about, I should have probably talked about in the beginning, is there's also a catalog in the infrastructure layer. So if I want to deploy NKP, the Kubernetes platform, which I didn't do through here, I can deploy it right through here. Okay. So again, we're making this very, very simple. And for our enterprise customers that need to deploy this at scale, we have what's called Zero Touch Framework, which leverages APIs to deploy everything in a fashion that's aligned to what your requirements are. So we can align you from the infrastructure layer to the platform services to NUS, all the way through your core application stacks, into all the way through configuration of those applications, right? So think of, like, we have retail customers, example, that want store in a box. We can deliver end-to-end store in a box that has their infrastructure stood up for them, all the way to the application configurations to ready to consume. So going through an automation called Zero Touch Framework, which takes you from, planning, right, all the way through the actual consumption and consumption readiness. It's easy to install something. It's very hard to get to. It's much harder and more time consuming to get to consumption readiness, right? Because then you have to integrate what you installed into your operations, into your tooling, right? Your observability, your IPAM, all the other third-party tooling, right, that you have. And then Zero Touch Framework actually does what's called drift detection. So if it drifts away from the configuration, we can detect that and then go back to the known good state. Okay, so at an enterprise scale perspective, I just wanted to throw that in there. You don't have to do all these things like I'm telling you how to deploy them. There's a way to do this automatically as well, all the way through your application layers and configuration. Okay, so now that you saw the Kubernetes layer, right? And I didn't get into this is not a deep dive again. This is not a deep dive on Nutanix platform or NKP, right? This is getting to AI services. So I want to get to that. So assume that I deployed the Nutanix Enterprise AI. I did it outside of NKP because I'm using the latest software and I want to make sure that right everything is supported because typically, not to sugarcoat it, typically the latest software, it takes a little while for the application catalogs, right, and all that to support the latest software. Okay. And so I've just installed it a different way, which you can do. So now let's get on to AI services because this is what we're here for. Okay. This is the Nutanix Enterprise AI solution. Okay. It basically is a agentic AI platform that provides management and operations, simplified management and operations around your inferencing, your model management, your external providers and routing through AI Gateway, your MCP connectors, right? And I'm going to show you what that looks like through the agent, right? All of those things. Your GPU scheduling is done at the back end on Kubernetes. So the marriage of this solution running on Kubernetes, running on NKP, and running using Kubernetes is extremely important. If you look at Nutanix Enterprise AI as the operating system for AI, the Kubernetes layer is the orchestration layer for AI. It orchestrates everything on the back end. So, for instance, when I download a model from Hugging Face, right? If I go into here and I import model from Hugging Face and I download that model, or I import a custom model, okay, it's going to create a Kubernetes job on the back end, okay, to actually go through that process. And then at the same time, because I'm using the CNI, or excuse me, the CSI for files, it's going to create a PVC to store that model on. So if I go into files, those PVCs that you saw, right? These are all the storage for the models. And it dynamically does that for you. Okay. And that's the beauty of it dynamically doing it because we're orchestrating through Kubernetes, right? Through API. Kubernetes is going through APIs as well, right? And orchestrating all of this. So when you have model readiness, now I can create my endpoints, right? In inference. And so I can create local endpoints, which you see here. I have the Gemma 4 model running. It's active. You can see here it's running, accelerated by the RTX 4000 SFF Ada. When I create that endpoint, Kubernetes is orchestrating the creation of that endpoint, and Envoy Gateway is giving you access to that endpoint. Okay, so when I click into this endpoint, I have my OpenAI API compatible endpoint URL that I can leverage, and I can send off to my developer with the API key. Okay, so if my developer needs an access to a model or an agent needs access to a model, right, then you would provide the access through API keys, right, and the endpoint URL. And I'm going to talk about this a little bit more in depth as we go through the agent demo in a minute. The other thing we provide is what's called unified endpoints. Okay, so this is using our unified gate, or excuse me, our enterprise AI gateway. Okay, and now I'm able to create unified endpoints. So you can see here, I have a unified endpoint that basically routes traffic to my local model. Right now I have 100% load going to local model or to any external provider model. Okay, and I can provide load balancing between the two. I can do failover between the two or three. I can do token limits. Okay, so customers are asking, how do I control my costs within the platform? Let me just look at the chat to make sure everything looks good. Yeah. How do I control my costs for AI inferencing with these providers, right? Like GPT-5, like OpenAI or Bedrock or Anthropic. Well, you can do that by using token limits and a unified endpoint. And you're controlling the routing, right, for your AI apps and your users through this unified endpoint. Okay. And that's the beauty of it. And because you can do that, you do that on-prem, you now have complete control, right? And there are other things that are going to be added to this, right? Like semantic routing to different models, right? And that's another thing that would control costs and make it more efficient. And so this unified endpoint is actually serving the AI agent, which we're going to get to in a few minutes. You can see here the providers. I have OpenAI as an example, but if I wanted to add different providers, I could add Anthropic, Bedrock, Azure OpenAI, GCP, Vertex, or another NAI endpoint, right? So maybe I have multiple NAI platforms or AI platforms or NAI endpoints that I want to route between, okay? And when you start looking at things like I said, semantic routing, you're going to have different models, different layers of models, and those models will have different levels of expertise, right? And you want to route those requests to the model that has that expertise, or a model that doesn't necessarily need to be a very large model. It could be an SLM that can handle the request, right? And that gives you more efficiency. And so this is what the unified endpoint provides. The other thing it provides is the ability to effectively manage how MCP is leveraged. So the biggest thing that customers, there's two big things I hear about MCP. First, it's heavy. It's a heavy protocol. It's a heavy standard from a context perspective. We get it, 100%. And now we're seeing, folks start using skills like what is the harness that you're going to use, right, for your AI agents, et cetera. And what we're seeing play out in real time is the combination of skills and MCP. MCP for specific use cases, skills for other use cases. Okay. And meaning it's not an either or, it may be an either or depending on the use case, but in a lot of cases, you're going to see a combination of these two come together. And a matter of fact, in my agent demo, I'm going to show you that. Okay. And so now I can add MCP servers. You can see here I have a Firecrawl MCP server. And I just did this as a demo. I have a Firecrawl MCP server running in my Kubernetes cluster, and I have a connector that's created with an API key that basically allows the agent and gives you control on what the agent can do with that MCP server, right? So you can see here I have my MCP client key connecting to my MCP server, and I only have one out of the three tools exposed to that agent. So now that agent only has access to use Firecrawl only for search. It can't scrape, right, a URL and return its contents as markdown, and it can't crawl a website starting from a URL and return all pages. Don't think of it like that. Think of it more, because this is kind of just an easy demo to show you. Think of it of a more in-depth MCP tool or MCP server, like for databases. Maybe you only want the agent to read data, right, but not write into specific areas or do specific things in a database. Or maybe you don't want it to do something, another MCP server that does many different things, opens many different tools, and you can say, okay, this agent only has access to do these specific things or access to these specific tools that are provided through this MCP server. Okay, so in my case, I'm only allowing search for the Firecrawl. Okay. The other thing you can do is fine tuning, right? So of course I'm using NFS. I want to fine tune a model using LoRa fine tuning. I can do that. I have my file share with the data I want to use, right? Basically it's in JSON-L format, right? It's sitting on my filer, and I want to be able to go into my models and I want to do some fine tuning. So I go and fine tune, or I show a base model like a Llama 3, let's just say a 3.2 instruct. I choose my Hammer NFS. I give my name, right? So whatever, Llama FT, fine tune. I hit next, right? I do some fine tuning parameters, right? The speed, the epochs, right? Learning rate, batch size, etc. I choose my accelerator. I choose my configuration, right? I hit next, and it goes through a fine tuning process. Okay, so you can fine tune within the platform as well. Now, I didn't talk about model access control. I should have talked about that first, but because it really all starts with models, doesn't it? So You have access to Hugging Face, which is the largest repository of open source models, as well as NVIDIA NGC, right? And so you have model access to those two, and we have a set of pre-validated models that you can download from NGC and Hugging Face, but you don't have to do that. Now, the reason why the pre-validated models are good is because we do some validation on what we expect from a performance perspective. We do brief security scans on the models, right, to make sure that they're validated. Of course, um, that's not a continuous scan, so you still need third-party tooling like Palo Alto, right, or a Cisco AI Defense, right? They provide the model scanning and those types of things, right? And so we would suggest you still go down that path, but from a pre-validated perspective, it's more about this is validated. We know it runs good on Nutanix. It performs well, right? We give you the infrastructure. So in a pre-validated model, when you deploy it, the infrastructures, the fields are already completed for you. You don't have to worry about doing that. Okay. But you can, right? You can provide control of these models, and you can say, okay, I can say only allow. So in Hugging Face, I'm only allowing 2 models to be used. If I went and downloaded this Google based patch, it wouldn't allow me to create an endpoint, right? It basically blocks you from creating an endpoint because it's not allowed. You can also allow direct upload download and manual upload. I have manual upload disabled, but I have direct download enabled for my user. Okay. Now the direct download, right, is much more customizable, right? So I can go in and I can download different models. As a matter of fact, the Gemma 4 model and the Quen models I'm using, they are direct downloads. They aren't part of the pre-validated model list. Okay. So I basically go in and I do import models from Hugging Face, and I'll go to import a model from Hugging Face manually. So what I'll do is I'll go to Hugging Face, right? And I'll look for the models I want and say I go to Quen, right? And I want to go to Quen models. I'll go to Quen and I'll look at the 3.6 just came out. Very good. Too big though. I can't run this on the GPU. I can only run a Quen 3. Very small version of Quen 3.5. So, and I've heard it. I think I've read yesterday the 3.6 is very, very fast actually. So again, I can go in here, right, and I can pick a model, and I can copy this URL, come back here, paste the URL in, right, select the model capabilities, right. This is your tagging, right, and then import the model and confirm. So as I do this, right, it's creating the job, right, and it's basically creating the PVC on the NFS mount, right, and storing that model for in NFS. So it's got downloading right now. So I go into Kubernetes layer. Let's go in there. Okay, get okay, get jobs. You can see here the job is running, right? You can see here that again, what are we doing? We're orchestrating all of this within Kubernetes. Okay, and that's what's actually happening here. And it'll process, right? It'll get the model ready. It'll be stored on the NFS mount, etc. And when it's ready, it'll become green. And then I can go in and I can create my endpoint, right? From that, choose my acceleration. Now, one thing I love about what we've added is the customizable features within what we call the VLLM sandbox. So I can go in and I can import different VLLM engines. So for Quen as an example, right, you have to download a specific version of VLLM that supports Quen or Gemma 4, right, or the latest Nemoclaw models, right, from NVIDIA as an example, right. You have to go out and you have to find what's supported, and then you can go in and do custom arguments. So let's take this model Llama as an example. Well, I won't do Llama. Yeah, I won't do Llama. Let's do Quen 354B. If I create an endpoint, we'll call it test. I'll just say text tool and reasoning. Model instance is 4B. Acceleration is GPU pass-through, RTX 4000, and API key. Okay, hit next. So now within here, I can come in and I can import from a VLM registry, right? Quen 3.5. That's what I'd have to use, by the way. And I can do custom arguments. So I can go in here and do custom arguments like trust, right? Remote code. I could do GPU utilization, right? All of those things. So any VLM argument, sorry, any VLM arguments, right? In the VLM docs, I can basically leverage within um, the VLM. We call it the VLLM sandbox, right? So I can do a lot of different things, right? From a context perspective, like what is my content, my max length, right? From a context perspective, all of those things. Okay, what is my D type, right? What is my, is it FP4? Is it NVFP4? Is it FP? Is it FP8? Is it bfloat 16? All of those. And then of course you have all of the observability. I think is extremely important that you get built right within here, right? So I can get metrics on usage. Wait, what is this? The Gemma 4, all the logs, the performance, and we'll show you this a little bit later. All the logging, right? So the logs are updated like right here for this endpoint. So instead of having to go into Kubernetes, so say you're not a Kubernetes operator, say you're a data scientist or an AI developer, and you just want to see what's happening in the logs, and you have access to AI and AI, but you don't have access to Kubernetes. So if I go in here and say K logs, is this the right model? Yeah. Oh, sorry. What did I do? Oh, might not be the same. Hang on. It's not the same, right? So I can go in, this is, I mean, I'm just looking at the logs from Kubernetes. It's the same thing, right? I'm getting the same thing. But as a Kubernetes, like an SRE, I can still see that, right? Because the SREs doesn't really care about NAI so much from getting that information. They're going to go into Kubernetes, the Kubernetes backend, right? And so you get that information. And so now we're addressing different personas, right? The platform engineer, the SRE, the infrastructure admin, the data scientist, the AI developer, right? We're addressing where information, who has access to what information they get, what's important to them, and where they should get it from, right? So, for example, an AI developer may want to see the performance, right? Not just the logs, but what's the usage or the performance of this, and what's my number of requests, what's my time to first token, right? But an SRE may want to go into the Kubernetes layer, right? And sorry, and they may want to go into Grafana, right? And they might want to see like some of the stuff, right, in dashboard. So I don't know if GPUs or so compute resources. Right. So they want to see what's going on in here. Here's what we're providing from the DCGM exporter in Grafana. So an SRE may want to come in here and drill further into that. Right. And so again, we're giving you this platform that can be that's accessible from all these different personas, right? For specific reasons. And that's extremely important for a platform. And that's the difference between a platform and a just a out of the box solution, right? Okay, so I'm way over. I do want to get into the agent, okay, a little bit. So if you guys would bear with me, usually I stop at noon. I'll probably go to 12:30 on this, but essentially, what I've done is I talked about OpenClaw and Nemoclaw as my first foray into this agentic use case. And what I did was I took a step back and did a little research. And I know I'm a week late with this. And one of the reasons I was a week late was I want to do a little bit more research. So what I found was that OpenClaw is a little bit more challenging to deploy on Kubernetes. Now I'm not saying you can't do it, but it is. And I found an alternative called Hermes, which is, and they're two different agent types. And I'll talk about the difference between the two if you don't know what Hermes is. So OpenClaw is really about access tooling, MCP, like CLI, all of those things, right? It's really focused on that. And Hermes is really focused on learning over time. Okay, and this is what I like. This is what actually moved me to the Hermes side, not side, but my first foray into this agentic use case, okay, of personal agents. Hermes basically has long memory, okay? So it basically has this long memory. It remembers from weeks ago the conversation you had. So you had this long memory storage, okay, which I really like. It also builds its own skills, okay, which I thought was incredible. This was very eye-opening. Okay, so when I first did this, I was having issues with connecting Hermes, my Hermes agent. I call him Neo, right? Just the matrix, because everything was done by the matrix. So I just called him Neo. Okay. And I say him, but I called it Neo. Okay. And I was connecting it, trying to connect it to the MCP server in the connector in Nutanix. I'm going to talk about how this is set up here in a few minutes. And I was having problems with that. And it turned out to be a TLS issue, which Cloud Code actually helped me figure out. Okay. But what Neo did was remarkable out of the blue. Okay. After it failed about 4 or 5 times, okay, and then I fixed it. I got it fixed through Claude Code, right? Neo recognized that it failed 4 or 5 times, understood that's fixed, and then it built an MCP connector triage skill. I couldn't believe it, right? It learned from what was happening, okay? It saw what the MCP connector worked, right? And now it works, and Firecrawl MCP is a valid MCP server, or excuse me, MCP accessible tool for Hermes. It then built a skill to go through a MCP connector triage. And I thought that was pretty remarkable on its own. I didn't tell it to do it. It just did it. Okay. And what I'm finding with Hermes as I use it more and more, right? It starts to do these things and learn on its own. Now, it's very similar to OpenClaw. You got to give it a persona, right? You give it this persona, you kind of tell it its core functions, right? All of these things, right, up front, so it knows what it is. And it right? And then you can enable or disable MCPs or skills as you see fit. But it also automatically builds skills. The other thing it does, which I found pretty remarkable, is reinforcement learning. It continues to go through a loop to reinforce and to better understand and better learn things to make it much, to basically up level its skill set, which I thought that was pretty remarkable as well. So it's not as robust. I will tell you this: it's not as popular as OpenClaw. Nowhere near as popular as OpenClaw. Okay, I think it only has maybe 20 something thousand likes on GitHub, whereas OpenClaw blew right up 500,000 or 1 million or whatever, right? But I'm starting to see it play out a little bit more, and I like the fact that it does those 3 things. Okay, now it does lack in the tooling, right? That like OpenClaw has better tooling, etc. Now the challenges around and I want to go back to the Kubernetes conversation. The challenges around Hermes and OpenClaw from a deployment perspective are really around how OpenClaw works. OpenClaw uses a gateway, okay? Hermes is more direct access. So when you do that, it's a little bit more challenging to deploy on Kubernetes. So I started with the easiest first, which was Hermes, and we'll start looking at OpenClaw. And it gets even harder when you start looking at Nemoclaw, because now Nemoclaw is a sandbox Kubernetes basically environment, right? That's what NVIDIA is providing, a sandboxed Kubernetes environment with the router and a gateway, right? With a router, excuse me, within that. And so now to layer that within a Kubernetes stack, right? It's like Inception, right? The deeper you go down, right? So it's a little bit harder to kind of get that right. And I will be focusing on that in the coming weeks. But I wanted to start with Hermes, and I thought it was a good thing. So I basically deployed Hermes, got it connected to Telegram, and I deployed this Firecrawl MCP server. So I showed you this already. This is running all in the same Kubernetes cluster. I know it's not best practice, right? You wouldn't do this in the enterprise. The MCP servers would be in their own Kubernetes cluster, right? All this would be separated. So don't think this is a production-ready platform, right? This is just art of the possible. But what I found really compelling was the ability within Nutanix Enterprise AI to control the agent's access to this MCP server right through the connector. So when I add the MCP server, I add it in, then I create a connector with an API key, right? And I can now enable the tools, right, that this agent, Hermes agent Neo, has access to. So let's go and look at Hermes really quick in Kubernetes, okay? So you can see here, pods, namespace. This is probably very small for you guys. Hermes agent, okay? And you can see here I have the agent and I have the MCP server, Firecrawl server, and it's running 2 replicas of the MCP Firecrawl, okay? And the Hermes agent is basically running 1. Now, if I want to go into it, right, and exec into it and look at what it has access to, right, I'll just exec into it and I'll go to the tools, right? And I can go in and I can look at, let me see if I can make this bigger, guys. I know this is probably view. Control plus, that's right. Okay. So you can see here, I'm in here and now I can do pretty similar. If you were to deploy this on a container or deploy it, on a VM, you would be able to do this as well, right? You can configure the CLI, right? And you can see here some of the things that the CLI has access, right? Now, some of the things require API keys like image generation, of course, right? Mixture of agents, right? You'd have to, RL training, Home Assistant, like those things require the brain. They require a model inference endpoint, okay? Some of these things do not, like file operations, terminal processes, right? Web search. Now, what I did do is I did turn off the web MCP tool and I replaced it with Firecrawl because Firecrawl now allows me to deploy an external, right, MCP server, which is what you would do in your environment. You would have external MCP servers running on different infrastructure, Kubernetes infrastructure, and you would need to access it, right? Control that access, right? Like a centralized location. And then you can do, configure Telegram, right? Which I've already done, right? So basically, this is how I interact, right, with the agent. I can configure all platforms, so I can do a lot of different things, right? Within the agent, I can reconfigure the API key, the MCP server, what MCPs it has access to, right? Right. You can see here, these are the built-in ones. So this right here, MCP server, 2 tools, get current time and convert time, are the built-in MCP servers. The Firecrawl MCP server is not built in, and therefore it won't list it here. Okay, but it is in the configuration template. So if I go in here, and I look at the configuration template, you can see here the MCP servers, and you can see here Firecrawl, right? And what I'm doing here is I'm basically pointing Firecrawl to the NAI connector, okay? And I'm providing the API key. So within, and by the way, you don't see it there, obviously, because I'm using an environment file, right? But so what I'm basically doing here is I'm providing it this URL, right, with this API key. So Hermes agent not only has access via API key, right, but also then when it has access, I only allow specific tools to be allowed, which is search. Okay. And I think that's pretty compelling from a security and governance perspective over MCP and over your agents. So this is Hermes, right? Agent, I call it Neo, right? You see I've been chatting with it. So let's just do, and by the way, it's not fast because it's an RTX 4000 SFF80, guys, right? It's not going to be like really fast. So let's just say hello, see what it comes back with, right? It's typing. So I'm going to do a couple things here. So you can see here, I'm ready when you are. Think of me as your specialized partner for all things infrastructure, Kubernetes, and cutting edge MLOps. So the persona I gave it was basically an agent that was an expert, right, in infrastructure, Kubernetes, and AI. Okay, and that way, if I wanted to do, get information or research or do things regarding those subjects, that it would be focused solely on that persona, right? That was the whole idea, right? So I'm going to go down here and say, search the web for information on best models for Hermes on RTX 4000 SFF ADA. Okay, so what this should do is, and you can see here, it's using the MCP Firecrawl, right? And now it's using the Firecrawl MCP server, and it's only allowing that search. So it's going to go out and it's going to get that information. And then you can go back here and you can see, right, these requests. There should be more requests here if I refresh. Maybe it hasn't come in yet. But essentially, these requests will come in. You'll see that they're successful, right? Obviously, there's inferencing that's happening on the unified endpoint. Let's look at that. Let's look at the metrics. You can see the token usage, right, is coming up. You can see Hermes responded. And now Hermes went out to the web using the MCP Firecrawl search MCP tool and provided me this overview, right, of what models are best for the RTX 4000 SSF ADA for 20 gigabytes of VRAM. Okay. So I just wanted to show you, again, I know this went long. I wanted to show you this quick demo, but this is just, and I want to do the MCP demo, not just the skills. We're going to do the skill stuff a little bit later. So as I build more on this Neo agent, right? This Neo Hermes agent that's running and connecting with unified endpoints. And by the way, if I wanted to, I could actually push this load to OpenAI, right? But because of the API token usage, again, this goes back to agents and the token utilization. I'm not going to go to OpenAI because I would blow out my free tier in like 10 minutes, right? So I'm not going to do that, right? So I'm using my local Gemma model, Gemma 4 model. I know it's a smaller model. I had to use the E4B because actually I'm very impressed with how small this model is and how smart it is. It's extremely good for how the size of the model. It being, a floating point 4 capable model, very small model, right? 4 billion parameter model, but very capable. GPT-5 mini, right? I could use that, but again, I would blow out my free tier in probably like 5-10 minutes. Okay. So I just wanted to show you that. And you could fail over, right? You could send it to Anthropic, right? Maybe you want to make it your Hermes agent an expert coder, right? And you want it to do code review as an example, and you can send it to Anthropic, which is great for coding, right? As a matter of fact, I'm not going to BS you here. I was helped a lot through this process with Claude Code, right? It really helped me triage some things, right? Go through some of this, and really helped me kind of fix some of the issues that I was having. But you could have a Hermes agent pointing to Claude Code as well, right? And doing kind of the same thing, doing some code review as an example. Maybe you want it to be the code reviewer that is the final say. Maybe you wouldn't probably want to do a final say, but that does the push right that does the commits and all that stuff. And maybe you give it access to Git, your Git solution. I didn't enable that because all of the issues that happen with OpenClaw with Git, I didn't enable the Git access for Hermes. So I'm a little bit more. It's a lot locked down, right? When I first deployed this, I had network policy that only allowed it to do certain things. I had some issues with that, so I opened up the outbound, but I have to go back and I have to relook into some of the network policies. If you think about where Flow CNI fits into that, you can lock down the agent through policies just in Flow CNI. So it makes it a much more streamlined solution versus me using, Kubernetes network policies and having to manage all of that. That becomes more of a nightmare. Okay. So again, I hope you guys enjoyed this one. I had a lot of fun building this, and we'll expand on this in the coming weeks. I said there was going to be 4 parts to this. There probably will be at least one more part to this since we skipped a week. And if you have any questions or you have any comments or you want to talk more about how I did this and how I got this working, or my experience with the platform and of course the Hermes agent, feel free to reach out. I'm happy to talk to you guys on LinkedIn. I hope you have a great rest of the weekend, a very productive week ahead, and I'm excited about where Agentic AI is going, and we'll be talking more about this here in the coming weeks or so. So again, wish you well, have a great day, and talk to you soon.